creating a custom deformer in Deform is pretty easy, but I will throw out a warning that you do need to have some knowledge of the Unity job system. That's a pretty integral part of the Deform asset framework system, whatever. So with that warning out of the way, let's get started and create a deformer. So I'm going to create a C# script, and I'll call this move deformer. That's the simplest deformer I can think of making, just one that moves the mesh forward, backward, left, right, up, down. So I'm going to get started by removing some unnecessary clutter from the script, and I'm going to put this in the deform namespace. You don't have to put it in here, but you do have to, well, you either have to put it in the deform namespace or be using the deform namespace, because this class needs to inherit from deformer, which is only available in the deform namespace. So we inherit from deformer, and we implement this one method that it needs, which is called process data. So again, you have to know how to use the job system because, as you can see, it returns a job handle and it is passed a job handle called dependency. So Deform is basically expecting you to create and schedule a job that is dependent on this dependency. So you're basically creating some work and adding it to the end of a dependency chain. And then Deform will process all of those jobs and tell them to complete, and then whatever you do in that is cool. Typically, what you do in that is deform or process the mesh data. So mesh data has vertices, normals, tangents, UVs, triangles, whatever, all the stuff you'd need for deforming a mesh, and it's all native arrays. So whatever you change in there is going to persist. Whatever you change in your job is going to persist, and then basically once all the deformers are done calculating, Deform will apply those native arrays to the mesh. So if you change the vertices, those vertices will get sent to the mesh that's being rendered. That's kind of how it works. So the first thing we need to do is create an actual job. So I'm going to create a private struct. It can be private, it can be public, it can be wherever you want. You just have to use this struct as your job. So I'm going to create a private struct called move deform job. Again, you can call it whatever you want. And then this is going to inherit from iJob parallel 4. So again, this is a struct kind of integral to the job system. It lets you run for loops across multiple threads. So we've got our iJob parallel 4, and we need to give it something to deform. So I'm going to create a native array, well, a public native array. Now again, I'm not using the namespace, so I'm going to use unity.collections, and this native array is going to hold float threes, because in deform, it doesn't operate on vector threes, vector twos, matrix 4x4, stuff like that. It actually uses the new mathematics library, which has a shader like syntax, and it basically just runs a lot faster and gets compiled by burst better, I guess. So it's just faster math library. That's the bottom line. So we're going to create native array that contains float threes. Now, yet again, I'm not using the right namespace. Now I am using unity.mathematics. We can create a native array of float threes, and I'll just call this, I'll try and call it vertices. Now, again, to move these vertices, we need to store how much we want to move them. So I'm going to create a float 3 called move. And in here, literally all we have to do is say vertices index plus equals move. And we're moving each vertice based off of this move vector. And then the job system will take care of splitting this work into chunks and sending them to multiple threads. So now we can go back. Now that we have our work that needs to be done, we need to actually instantiate it. So I'm going to say new move deform job, and then I'm going to open up some brackets to assign its value. So we'll say move equals, well, we don't have a parameter yet, so I'm going to create a parameter. I'll call this, it'll be a public vector 3 called move. Now again, you can, not again, but you can, float threes and vector threes can cast between each other automatically. So you can just create a vector 3 here and it works. So say move equals move, and then vertices equals data dot dynamic, if I can spell, dynamic native data. So this is basically an object that holds all of the normals, tangents, triangles, UVs, vertices, etc. In native arrays. And basically once all of the deformers are finished calculating, Deform will just take whatever's in these vertices and it'll send it to the mesh. So it'll say mesh.vertices equals these vertices, essentially. So we're going to say vertices equals data.dynamic data.vertices. So now we've created a job and we've assigned move and vertices correctly. So what we actually need to do is create a job handle, is get a handle to this work. And to do that, we have to schedule it because this method, Deform is not expecting us to return a job. It's expecting us to return a handle to some work that has been scheduled. So we're going to schedule it. It wants an array length. So we could say data.dynamicNativeData.vertices.length, or we can actually just say data.length, which is just a shortcut to that, just so you don't have to type out that long mouthful of text. Now, inner loop batch count. This is how much work is done in each chunk, so how many iterations on the for loop is done in each batch. So there's actually a default value called batch count. You can override this or just pass in your own value and ignore it completely. 64 is a pretty decent default value, but you can, of course, and you should tweak this to find what gets the best performance for you. And last but not least, we have to assign the dependency because Deform wants us to stack this work on to this handle that points to the end of some already scheduled work. So we're creating this big chain of work. And then, of course, we have to return this handle that we've just created. So we're creating a job right here, and then we're scheduling it immediately, and then and the schedule method returns a handle to the work that is scheduled, and we're returning that. So now actually, if we go back to the editor and we add this deformer, so I'll just grab a cube, and then I'm going to make sure I add a deformable component, and then I'll add the move deformer and add it to the deformable. And now you can see the mesh is moving. You can change X, Y, Z, pretty cool. And even if I go into play mode here and I open the profiler, you can actually see right here the work being run on each thread. So all of this work is running at the same time. You can see we've got a move deform job. This current batch of work, this instance of work took 0.071 milliseconds. It's pretty cool. And then you can see in total, the entire job to finish, it took 0.5 milliseconds. So you can scroll around, and obviously it doesn't take the exact same amount of time each time, whatever. So, but we can actually get this to run faster, and that is by using the burst compiler. And this is literally just Unity magic. So I'm gonna type burst compile, and then I'm not using the right namespace, so I'm gonna add that. I'll just organize a little bit. Burst compile. So just like that, it's gonna run faster. That's just how it works. It basically tells Unity to compile it with the special compiler that kind of works really well with native arrays and the new mathematics library and the job system. So you can see if I go here, I have to scroll in extremely far to see the work. So this one batch is taking 0.003 milliseconds. The entire thing is taking 0.046 milliseconds, the entire job. So the entire operation running over every vertex of the mesh is taking less time than just one of the batches without it being compiled by burst. So that's why you want to use burst compiler. I have not run into a reason why you wouldn't want to use it yet. It just makes your code ridiculously fast. So cool. And then one last thing I'll show you is you can actually add, you can see here, I've got this window pulled up that has a list of the current deformers. If you want your deformer that you make to be added here, just go to your class and add a deformer attribute and then say name equals, and I'll call this move. And then you have to determine the type. So the type will be type of move deformer. And then there's some other options you can give, like the whether or not it's a utility deformer, and then if you want like a default X, Y, Z rotation for the deformer when it's created. So now I've added this attribute, come back to Unity, and you should see it pop up on the list. Yep, right here. And now if I actually, here, I'll clear this out and remove this deformer. And now if I actually hit move, you'll see it creates a separate object with the deformer script on it. And the reason it creates a separate object is because most deformers work in world space. This one doesn't because we haven't set it up to do that. But so it creates a separate object, adds the component to it, and then adds that component to, if you have a deformable selected, it'll add that new deformer to it. So you can see it's right here. It got added automatically. And then we can obviously move it like that. So there you go. Pretty cool. Just a simple deformer. You can obviously do a lot more. There's a lot more stuff you have access to in the mesh data, and you can do some cool stuff.